name's Robert Sadowski. I usually go by Bob, and I'm the Army's Chief Roboticist, or otherwise known as the Senior Research Scientist for Robotics. I chair the RDECOM community of practice in robotics. So what I try to do, and my principal job mission, is to try and look at S&T development across the enterprise for getting robotics and autonomous systems within the formation. There's always the technology aspect of robotics and autonomous systems. Can I automate certain functions? So the Russians, for example, have something called a Uran 9. It's about 11 tons rather. It has basically a 30mm cannon on it. It looks like a small platform. It has additional capability as well. And they fielded it and worked with it. They also have something called a Platform M. They also have another platform that they've used in Syria as well. So the interesting piece about all this push towards robotics and autonomous systems is that even though technically they fielded solutions right now, and they're working with them, the US is actively engaged in trying to figure out how to incorporate these within the ground combat sphere. How do we stay ahead? Well, the way that we stay ahead in the past is not just a technology solution, it's also how you integrate that within the formation. The tactics, the techniques, the procedures. The amount of time that you actually train with those systems in real life scenarios, and that ability to do that sort of training and indoctrination with strategy and doctrine is actually where the Army usually does a much better job with our coalition partners. So that's how we try to stay ahead. The other way is on the technology side, is making sure that we develop modular architectured platforms so that as we can leverage the best and brightest in the nation, or startups or innovation, so that we can plug those advanced capabilities into our platforms at a speed so that we can keep that technological edge as well as we keep the training edge that we tend to have. We have used robots in combat for quite a while. We used them in Afghanistan and Iraq to do predominantly what was known as the counter-IED mission, and also to go look into buildings and also look into tunnels and a few of those other places. Those small robotic systems still exist, and we're actually ongoing a program of replacing those Talons and those backbot equivalents. But what you're really asking is, how do I get those larger robotic systems actually out into the force? We've been focusing for quite a while on logistics, and you'll actually start to see some logistics robots going to soldiers to be actively played with within the next 2 years. And so one of the programs that we have is known as Automated Ground Resupply, and it is actually taking palletized load system trucks. These are like 30-ton vehicles that can haul equipment, and we're actually converting them to enable them to be in what we call leader-follower. Manned leader and up to 7 followers. We're going to be building roughly 100 of those systems, putting 60 on for 2 truck companies to play with for an entire year. That's big, heavy Army moving logistics. And what that does is enables us to take 2 folks out of the cab. If the commander wants it, you can put 1 person in the cab, or you can put 2 people in there. But it gives the commander options so that he can increase his throughput. And that will be played with soldiers for a year. The second one is for the light infantry soldier, is we're actually doing what's known as the Squad Multi-Purpose Equipment Transport, or SMET. This basically hauls the soldiers' rucksacks, has a generator on it, and trails behind them. That is going to, within the next year, you're actually going to see that also go to what we call an operational tech demonstration, which is really a warfighter jury who plays with these systems. These systems, there are 3 unmanned, totally unmanned variant, and 1 optionally manned variant. And that has been announced who those folks are. It's Polaris, HDT, How and How, and GD. And those systems, the soldiers are going to play with them, and they're going to break them, they're going to fold them, they're going to mutilate them. That's what soldiers do. But they're also going to figure out new ways to use it and say, what do I need to do with this? I need to have litter bearers. I need to have something else I want to put on my unmanned platform, whether it be a weapon, whether it be a comms relay, so on and so forth. So you're starting to see the Army get very serious about putting capability in the hands of soldiers. Within the next 2 years, you're actually going to see soldiers coming back and saying, we want more of this, we want more, and then the Army making big decisions on how to go forward. The last piece is, which has grown out of our combat vehicle program, is looking at weaponized robotics safely. These are weaponized robots that are still controlled by a human. It's just that, can I offset the danger so that maybe the robot with heavy weapons goes in first behind a manned platform, integrated within the formation. The goal being to have robots out front so that more soldiers come back whole and alive, and that the robots are the ones initiating combat. And you'll see this in what we call our Joint Concept Technology Demonstrator, which feeds into combat vehicle robotics, which is two of our major programs where we're actually putting machine guns on small platforms to get the safety certification process worked through and make sure we understand what soldiers need to make these systems operate. It's an ongoing project safely and effectively, and then we're taking it out to a gunnery range and actually firing the systems to see if they can perform as good as a manned team. So we start that man-on-man teaming process. So those are 3 quick examples of something that you're going to see in ground vehicle robotics within the next 2 years to kind of help accelerate and get us to accelerate and understand how to incorporate these technologies within the formation. The largest challenge is how do you maintain assured control of your platform? Because really, if you talk about man-on-man teaming, I'll understand how you'll operate because I'll train with you. And I'll understand your strengths, your weaknesses, what you can do and what you can't do. As we start partially roboticizing part of the forces to give us enhanced capability and survivability in a lighter package, I have to work on that sort of man-on-man team and get to that trust factor. It's not just a matter of trust that I know what the robot's going to do in certain situations, it's also the trust factor that I can talk to that robot and I know what it's thinking, so to speak, and it can do that in a natural language process that is tactically relevant, because soldiers speak a little bit differently, okay, but they do have a sort of syntactical speech to understand. And so making sure you can have a natural relationship with that unmanned system, that's probably the greatest challenge, and I would say the greatest warfighter challenge that we're going to have to overcome, and guaranteeing that we have that sort of level of assurance of what we call assured control of that system. It's both cyber, it's also operational as well. We have actually had autonomous weapons for a long time. Many times, some of the earliest missiles that we ever developed were called anti-radiation missiles, and they would be fired at a target, and then if that target went quiet, they had a search pattern to look for other targets. So there's a very strict process that you have to go through in terms of weaponization of any system. Everything has to be what's known as DoD 3000.09 compliant, okay, which has, if it's publicly available, and it's really interesting to read through all the checks and balances that we put into place. But in the end, it's all about humans making control over lethality decisions. So the Joint Concept Technology Demonstrator, where we're starting off with a machine gun, moving to a larger caliber device, a 50 cal, and ultimately to something larger, is all about that process of weaponization, making sure that you have human positive ID and positive human control whenever you make a lethality decision. And so that's kind of where we're going with the weaponized robotics. Nobody wants a killer robot on the battlefield that isn't under human control. And so we are taking cautious steps, because again, all I'm trying to do is offset the danger. Okay, and that's the approach that we're taking. We've been doing military logistics robots for quite a while, and we realized that we could not get to what you would call SAE level 5. So we sort of took this approach to crawl, walk, run, and it's been wonderful to kind of see many of the same things that we've been doing for about the last decade. Actually, the commercial industry is saying, hey, you got to do it this way, you got to do it this way, whether it be redundancy of control systems, which we have to do when you take people out of the cab, just like the Bosch talked about today. Whether it be having to kind of think about mapping and perception in a different way, which you kind of heard the talk from the Toyota folks, research folks as well, that perception, and particularly trying to figure out what people are actually doing, you know, is a challenge that's still open. Realizing that you're going to have, this is a team effort, so you're going to have a sort of open systems architecture approach, so that I can take the best technology and plug it in as appropriate, it's been a pretty good highlight. I'm actually looking forward to Tim Wong's talk, because NVIDIA and what the work that they have done to get cheap, deep learning computing power that actually has a power budget and a cost budget for small platforms, because the military is very cost conscious, particularly when we have to field thousands of something. And since we don't build very large production runs, we have to be able to leverage the commercial industry, particularly in this space, to get us the sensors, get us the processors, the safety certification processes in terms of code certainty and all, that we're all going to have to need. So I've been really excited to kind of see those talks. And it's always great to go talk to the vendors in their shows. Because there's some neat demos that are being done out there. I'm looking forward to the FLIR demo where Now I see an infrared and I don't see headlights blaring me in the eye, and I kind of wish I had that on my car. I appreciate the opportunity to come here and speak, particularly on behalf of what the defense industries are looking for, because this is one of those cases where it is a true partnership. We work with a number of OEMs that are just not traditional defense contractors. We also work with a lot of the same folks that these folks are working with. And we use a lot of the same capability. I use Velodyne LiDARs, I use FLIR cameras. I'm using some of the software bits in terms of surety bits from EdgeCase, SQUERY, DCS. The whole point is it's a team effort. And really, if the America is going to lead in this space, and that's I want America to lead in this space, you know, is we really have to look at this approach a little bit differently than we have in the past. And it's actually exciting to kind of see some of these technologies actually coming to fruition. It's kind of sad in a way, because when you're doing research in this area, you were like king of the road. You're no longer king of the road. There's so many other folks who are helping build that effective effort and team.